Hey, it's October and Christmas is coming and the leaves are turning and we've even seen a little snow here in Utah. It's late October. And so it's time to start thinking about projects we can do for Christmas. This is my first project. This is a project that was given to me by a good friend of mine, Wayne Mack. And he's a great woodworker, lives in Essex in England. And he shared this toy box project. So what you can see on the screen is the file that he sent to me. Before I'm ready to run it on my machine, there are a few things that I need to do to make sure that everything's run smoothly. So the first step in running an unknown piece of code is to go to the job setup screen. Now I'm going to cancel this for a minute, and you probably know where to find this, but I'm going to go to the edit drop down, and I'm going to come down to job size and position. And that's going to tell me how Wayne set it up for his machine. So we'll just start in the upper left-hand corner. It's a single-sided part. Double-sided and rotary parts will probably handle in a different project. I'm using double-sided in some door projects that I'm making right now. Now we can see that Wayne works in metric, in millimeters, and that's the way his material comes, the thickness, that's the way basically he thinks and works. But Aspire is so brilliant that all I have to do is select inches and everything is instantly converted for me. Now my material is also slightly different. So I have a 97-inch long piece of MDF and I have a 49-inch wide piece of MDF and a 3/4 inch thick piece of MDF. Now the other thing that's different is I've set up my system so that I run on 0 on the machine bed. Lots of people set up on the top. It's an easy, fast way to set up. But when you run lots of sheet goods and you run the same kind of sheet goods, most of the time, setting up off the bed allows you to eliminate the touch off the material step. So that's what I do whenever I can. In this case, 0 is the bed of the machine. And that means that if the bit came down and touched the surface, it would be at 0.75. If it was set up on the material surface, when it touched the surface, it would be at 0. If I drilled in 1/4 of an inch, then it would go down from, if the surface, or on the machine bed, it would go from 750 to 0.5. The opposite would be true if it was a material surface. It would go from 0 to minus 0.25. Okay, that being said, the obvious thing is if I don't change this, then the program is written from the surface, but I'm running on the bed, it will try and drill clear through the material to start its cut. So this is just probably the most important step. Lots of people do it the way I do. Lots of people go off the surface. Just double check and find out how the other fellow who's given you the program is running, and make sure you set up your machine that way when you run this part. You can change if you want, but just this is my surface. I don't want to have to touch off, so I'm going to go here. The datum point is in the bottom left-hand corner here. If we get on the screen here, the operator would be standing here. The tool changer is down on this end. So this would be on the right-hand side closest to the operator. That would be my 0 point. So I've set up the first most important step is make sure my job is set up correctly. The next thing we'll go on to is, do we have the tool set up the same as Wayne? Do we have the tool pass the same speeds and the same run times and same depths of cut as Wayne does? So we're going to check those one at a time as we go through this. So I'm going to hit OK, and that's going to let us go back. Now, if anything changed, and it has, then it wants to recalculate everything. Every time it asks recalculate, I say yes, and we've recalculated. All right. Now, here is our program, and if you look at this, you see 2 identical parts, and you see here 2 identical parts here. These are one's turned, but they're identical parts. So this is 2 toy boxes, and there are a couple of tools that are going to be used to set this up. So I'm going to go over here and look at the tools that he's using. And we'll do a little interpretation. I may even go change these. So he's using a 2mm hole, drilled hole, a drilling process, to put in these holes here. These are for the stays, and down here on the lid, these are going to hold in my kitchen hinges, my European style kitchen hinges, all right? Then I have the 450 millimeter. That, for those of us using inches, that's about 0.17, or 0.177. A 3/16 of an inch drill will do that job if you want to change that. And then we have 6 millimeter for the cam pockets. We have a couple other things here. So I'm going to look at these tools next, and then look at the tools, and then I'm going to pay a close attention to the actual cut depths and things. So I'm going to go to 2 millimeter, and I'm going to look in my library to see if I have something that's similar. So if I go down here to my Maverick tools, then 2 millimeters is about 0.085. That would also be about a 3/32. Is close enough to that. So I'm going to change this, and I'm going to change my description. Now over here I have to apply that, sorry. All right, so I put the right tool in here. Nope, I haven't. I didn't apply that. I've got my recording bar in the way. So now I've got this, and I will change this to 0.085 and calculate that. Sorry about the delay there. The 4.5 millimeter, like I said, it's about 177. 3/16 is close enough. So if I change this to my 3/16, then I can change this. This is the depth in inches. I'm going to come down here and just change this to 0.188 and calculate that. Then I'm going to go down and do my cam pockets. Okay, so these are the small pockets up here. These toy boxes are held together with cam and posts. You see this kind of hardware in IKEA stuff. So the cam and post, we need the cam pocket for the cast cam, and then we need some drilled holes. The 4 millimeters that we just did were the drilled holes. So we can cut this with a 6 millimeter drill or 6 millimeter end mill. Because I've been working with Wayne a lot, I carry a lot of 6 millimeter end mills. They're really inexpensive and they're good quality bits. So I buy them and use those in place of a 1/4 inch. Just for your information, 6 millimeters about 250 or 236. A 1/4 inch is 250. So with about 14 thousandths difference. So for this job, I'm just going to leave that tool together. All right. So these are my hinge pockets, my cam pockets, my hinge pockets, and a few other things that I have here. So I'm going to, let's have a look at this, and let's preview some of these tool paths. So if I preview those pockets, and then my hinge pockets, those are for the cabinet hinges. Those are the grooves that the bottom panel is going to sit into. Those are a cutout that I'm going to use for my inset panel. We're going to make this so it can be personalized easily with a panel either flat with letters that are glued to it or stuck to it, or we could put a raised panel in there. We could do a textured panel, something to give it a little bit more sparkle and shine. This is my preview of my outside cut, and I have a problem here. It's skipping some lines here because of my offset. I'm going to have to adjust my offset. And then this is the actual finished cut. And you'll see that here there's a little light coming through. So we've cut through the material. So what I do is I don't use tabs anymore, or I use them if I have to. But with this kind of a job, I prefer to use an onion scan. So I know my material is 750. So if I go to my first outer cut, then let's just look at this one for a minute. What are we going to do with this? We're going to go to almost through the material, so about 730. Leave about 20 thousandths of material waiting there. And then I'm also going to make an offset here. Now Wayne uses every bit of the wood, every bit of the material. So I'm just going to step off just a little bit. So I'm going to go off 4 thousandths of an inch or half a hair, so that I don't go right up against the finished edge. I have a little bit of material to take off on my final pass. So I'm also going to look at a couple of things. I'm kind of jumbling this together, but stick with me, we'll be all right. So I'm going to check my RPM on these cutters. About 18,000 is fine. and 350 inches a minute with a plunge rate of 175, that's just fine. So we will go ahead and calculate that. All right, now I want to go back to my preview page, and we'll reset the preview, and we're going to look and see if that gives me full cuts all the way to the bottom. And no, it does not. So what did I do here? My offset. Boy, he does not waste any space at all. I'm going to change this offset. Let's go with 3 thousandths and see if that's going to give me close enough. So you can see that each one of these cuts is going to overlap the cut next to it. There will be so little waste. So I'm going to reset and then just preview this one. All right, so that's good. And then this is my finish pass, and it will have no offset here. It will go to 765, about 15 thousandths through the material into my spoil board. Marks my spoil board up a little bit, but it gives me a good clean edge on the bottom. I'm going to edit this and look at this part here, and I'm going to look at the feed rate. So I'm going to be about 250, a little slower because I want a clean edge, and this will be 125, and we'll do this. Now, because I'm using an onion skin, I'll have to go back and look at it. I do not want to ramp. I ramp most of my cuts, but I do not want to have a ramp on this. I want it to start in a corner. I like this corner closest to me here. So it's going to start in the corner of each one of the parts, work its way around, and cut away that oil or that little onion skin. So there will be very small cuts, but everything will stay in place, and I won't need to go sand away any tabs when I finish that. So I'll calculate that. That's going to go through there. Okay. Now I added this. Let's just give you the view. I added these 2 cuts here, and originally I was going to cut them with a metric bit, but I'm going to go and use my 1/2 inch compression bit, which is in my tool slot number 1. I'm going to calculate that. And this is the other one, and I'm going to do the same here. And I'm going to come down and use my, my compression bit again. And since I'm using an additional compression bit, I'm going to also go to the hinge pockets here. And I'm going to change this to 0.5. And I'm going to remove this one and select the same bit. So down here in my Maverick tools, I'll calculate this. Okay, now if you use this, you won't mind the detour too much. If you don't use this, I hope this helps you out, but I'm going to go create a job sheet, and I'm going to just put this, for now, I'm just going to call it Test Henry. Oh, got to put the right letters in there. And it really doesn't matter. When I bring up that file, so here my recents should be sitting right, come on, should be sitting right here. There's Test Henry. Now this tells me about my material, tells me I'm on the bottom of the material. I'm in the bottom left-hand corner if I'm standing on the side of the machine, the right closest corner, right nearest corner if I'm standing by the controller. My home position is 0, 0. Everything about here is just fine. This is the amount of material I want to be above the part, so I'm looking good. And I have updated. I have 2, 3, 4, 4, 1, 1, 4, 4, 1. Now, that doesn't make a lot of sense to jump back and forth, put in number 4, do a couple of cuts, then go to number 1, then come to 1 down here. So let's go back and look at these real quickly. And we don't need that. We don't need this. There we go. Sorry about all the clutter. I was doing another project when I started this. So this hinge pocket is going to be a 1/2 inch. And these two are going to be 1/2 inch. I'm going to raise those up. So I'm just going to take the hinge pocket to put it right after the drill. I'm going to take the inside edge, and it doesn't really matter what order I do, inside or outside, but I'm going to put that after the hinge pockets, and then I'm going to come down to the outside edge. And those should now be in order. So I'm going to create another job sheet. We'll just throw it under the Henry test and say, yeah, we want to look at it that way. And my recents should come up as test Henry. So now my tools should make more sense. I'm going to drill the 085 drill. I like to do my drilling first, then the 188 drill. I'm going to use the 1/2 inch compression bit on 3 different operations. I'm going to finish up with all 4 or 6 millimeter bits in station 4. So that all looks really good. Let's just take a quick second and go down to one of these that we understand. Here's hinge pockets. It's going to tell me what bit I'm going to use. Okay, it's a 1/2 inch compression bit. It's going to tell me the spindle speed. Everything I need to know about these setups that are in the program will be on the setup sheet. I like to take this out to the machine with me so I can just double check. So this is the depth of the cut here, right, when I'm cutting the pocket. But this is the pass depth. The pass depth that I set for the tool says I don't want to cut any deeper than this because I'm worried about it not having enough horsepower or whatever. So I'm going to do this 571 in 2 steps, obviously. Now it won't go 0.4 and then 0.171. It will go half of 571 because I've said this is less than that. But I can do the whole depth at one time, and so I'm going to change that. I'm going to look at this pocket. Now this is, the pass depth is bigger than that. That's good. And then this is bigger than that. That's fine. So that'll do it in a single pass. And down here in the cam pockets, those are the small pockets. This is still sitting in metric, so we'll have to work on that. So we'll look at we've got the tools in the order we want. Let's go to look at each individual tool and see what we've got. So if we look at the 085 drill, then let's look at all of its parameters. So it's a 2 flute drill. That's fine. The pass depth is 0.6. Up here, my cut depth is 0.2. I'm going to change that. But I am in tool number, and I can drill at 40 inches a minute. This is very, very important. Drill bits are thin, and they're not balanced. So if you spun at 25,000 RPM, not only would it cause a fire or at least burn your wood, it would also be unnecessary and probably would result in the bits snapping off and flying across your room. So check your bits. Drilling 5,000 is as fast as you want to go, 5,000 to 6,000, but never go faster than that. So I'm going to look at all this and say, well, this is all fine. We can apply that. But my drill, these are pilots for my hinges. I'm going to go a 1/2 inch deep, and we can go ahead and calculate that now. I'm going to bring back this screen for a second because I saw this as it flashed away. Peck drilling allows me to drill a little bit and then drill a little bit more and then a little bit deeper and then finally get to the bottom of the hole. And that's controlled by the pass depth. So if you want to have it drill a lot of small pecks because you're in very hard material, then you can do that. Use this tool. But in particle board or in MDF, that's not necessary. Let's go up and look at this tool. So we'll go back to our 188 drill and we'll look at its parameters. It's 6,000. That's going to be fine. 40 and tool number 3. That's all fine. And my depth on that is also going to be about 0.55 is what I like to use. It got converted from metric. So we're not going to peck drill. We are going to drill. Okay. My hinge pockets, we're using that 1/2 inch compression bit. If we hit the edit button, we can go look at the parameters there. 16,000 RPM, 300 inches a minute, tool number 1, that's all good. The depth, the pass depth is 0.4. Over here I can see that I want to go 0.57. So I'm going to change this to 0.6. There's no need in taking 2 passes at something that shallow. So I will calculate that. And then these, let's just quickly make sure that the depth of cut is not, or does it, the pass depth, I'm sorry, I'm mumbling away here. The pass depth is bigger than that. It is, so we're good to go. We'll check the other one. Shouldn't be any different because these are set up in the tool parameters. So we're going to go 0.39 deep. If we edit this, then 0.4, so we're good. And that leaves us with our 6 millimeter. So let's have a look at these tools. So the 6 millimeter tool, I don't actually have this in my library, but it comes up and it has its own parameters. And if I use the edit and not the select, I can see what Wayne has everything set up. So he's at 18,000. The feed rate's about 150. Half of that is his plunge rate. And so there's nothing wrong with that. The diameter is 6 millimeters. So it's 6.5 millimeters. And so I'm going to change this to inches. No, I'm not. I'm going to have to do a little quick calculating. Now I'm going to go to inches. What the hey? No, I got to go stay with millimeters. So my pass depth, I want to go 1/2 inch. I do the math in my head. That's about 12 millimeters. So if I put this at 15 millimeters, it will drill, or it will cut that pocket in the single pass. So that's all right. Okay. I don't need to ramp these moves, so I'll pass that. Well, actually, I'm going to ramp these. It's going into those little pockets. Okay. Now these are the panels, or the grooves that the base panel is going to fit into. So let's have a look at it's 4/10 deep. So this isn't going to be deep enough. This has to be back to about 15. So it does it in a single pass. 18,000 is fine. 300, 150, that's all right. So that is that one. Now the other outer cut, we want to go almost through the material. Let's look at what our cut conditions look like. It has to go 7.3 dig. The pass depth, 24.5 or 25.4. I forget. But 25 roughly is about 25 millimeters is about 1 inch. So if I want to go to 750, let's just be careful, or let's just be sure and say we're going to go 25 millimeters per pass. That will get to that depth in a single pass. I'm happy with that. We'll calculate that. All right. Let's look at this one. Come on. We're going to probably have to do the same thing. So we're going to go up here. That's 20 millimeters. We're going to call it 25 so we don't have a problem. I'm slowing that down a little bit as I do the finish pass. I don't have any offset, and I'm going clear through the material, so everything looks great there. So now when I calculate this, I should have everything I want. Now I won't print this out, but I am going to create a final worksheet there. Can't speak and type at the same time. I'm sorry. Brain doesn't multifunction. So that's my final setup sheet. If I go down here and look at my files, then I can come on. There we go. There's the final. Let's just double check everything here. So if we look through this, we're on the bottom of the material. That's the way I have everything set up in my system. The bottom left-hand corner, that's my blank size. 2, 3, 1, 1, 1, 4, 4, 4, 4, 4. everything looks just fine from here. So this gives me an opportunity. If I have a short memory, I can check it here and check the box. But if I were headed home today and was going to come and run this part in the morning, printing this out so I have it to look at just to refresh my memory is a good practice. All right, we spent 25 minutes so far showing you how to get this ready to go. All I'm going to do here is go to close this out and use the icon over here to save the toolpath. And I'm going to save this toolpath into the same directory. So I'm just going to say this. Not toolbox, toybox. So that's Henry Toybox. So I can take that out to my computer on a thumb drive, plug it into the CNC, and I'm good to go. So it's taken a few minutes to go through all this, but these are all things whenever you get into an unfamiliar program, you don't know who wrote it or what they have all about, what they were thinking, then you want to go through this checklist. Now, just for fun, I can turn this off here so you can see this. I've created a document that I can use, and you can get a PDF of this document, but this is what I use. And I grabbed the graphic, did a snippet and grabbed the graphic. This is the way I found it. Each one of these data points, or each one of these parameters is defined. And there's some cautions in here, things that you need to watch out for. And then this is the last of the definitions, and then here's the actual setup page after I changed everything. So these are the setups. So now my setup and my job is set up the right way. And then I'm just going to print this out. And if you would like to get a copy of this, you can always drop me an email. All right, or put a comment in the page. All right, this is printing. I'll ignore this now, save it, and put it away for now. And that pretty much wrapped things up for me. The next thing you'll see is I'll be in the shop. We'll be cutting parts, and then the last phase will be we're going to be assembling the toy boxes, and I'm going to explain how to use the cam, the cam and post, the hardware, the drill fixture we need to be able to do that. So that'll be kind of fun to see that, I think, anyway. But this is a great project, and we'll move along a little bit later, probably in the morning. It's late in the day here. All right, see you next time.